In this video, we are going to be starting our periodic table unit. So obviously you need to have your periodic tables handy for these notes. We are going to talk about the organization of the periodic table and how the elements are very systematically placed so that by the end of the unit, we will be very good at predicting the properties of an element just based upon its location on the periodic table. So the periodic table arranges all of the known elements in a very systematic way according to their properties. So we will be looking at various properties throughout the unit and how these properties change as you either move down the table or across the table. Again, by the time we get to the end of the unit, we will be very good at predicting properties of the element just based upon where it is located on the table. At this point in time, there are 118 known elements. Some of them were recently named. Any of the ones that you see, like UUP, element 115, the UU ones are awaiting approval and awaiting for their formal name. So UUs are kind of in a holding pattern. Most of our elements are naturally occurring. The rest are man-made through nuclear reactions. And most of our elements have been around for a long time. The elements that are man-made through nuclear reactions, those are obviously. Now, as you've already begun to realize, a lot of the symbols match their names very closely, like hydrogen is H, lithium is Li, carbon is C. Those ones make sense. Some of them feel like they don't really match their name. When that's the case, they do typically match their name in another language. Often it's in Latin because these were discovered so long ago. So below, this is not anything that you have to memorize. It just gives you some background information so that you know why sodium is Na. There are some other ones that were named in honor of people, like Rutherfordium. You remember Rutherford did the gold foil experiment and discovered the nucleus. So he did not discover that element. It was named in honor of him. Californium was discovered at Caltech. So that's where its name came from. Then you have ones like francium was obviously discovered in France. And that leads us to this slide here. This, again, nothing that you're going to be tested on, but I think it's interesting. It shows you the different nations that have discovered various elements. So you see there's ones like copper that just basically has always been known, so it's known to ancients. Then you've got some United Kingdom ones. You've got a bunch of ones that were discovered in the United States. Those ones were all made through nuclear reactions. AM, we have americium because we couldn't, have francium and germanium without an americium. There are even a few that were discovered in collaboration. So if you see the two flags, that's what that means. So, what I would like you to take from this is just like the atom, the history and development of the periodic table has occurred over a number of years and still continues to change a little bit today as new elements are discovered. So, if we go way back in time to 1869, Dmitri Mendeleev, he organized the first periodic table. So he also has an element that is named after him. So he organized the first periodic table and saw that whenever there was a repeat in patterns, he put that element below. So we have his group one. Notice a lot of the stuff in his group one is still in our group one. So hydrogen, lithium, sodium, potassium, copper's also in there, rubidium, silver, cesium. So most of those are still currently in group one today. If you take a look at the electron configuration, everything that in group one has one valence electron. Copper also has one valence electron, so it makes sense that Mendeleev put that in group one. So in Mendeleev's table, and Mendeleev was a Russian chemist, he arranged elements in rows based upon the atomic mass, and there were 63 elements at the time. So we know that our modern 69, they didn't know that there was protons in an atom, so it would have been very difficult to arrange the periodic table by protons. So Mendeleev arranged it by increasing mass, and when he saw a repeat in properties, he started a new row. So in other words, if he had sodium in its spot, then he saw a repeat in properties. Potassium behaves a lot like sodium, so therefore he put potassium below sodium. So that ended up with elements that had similar properties being in the same columns. And then this is the interesting thing. If no known element had the properties that he was anticipating, he left that space blank. And he assumed that there was elements that fit those properties, they just hadn't been discovered yet. And he actually did a really great job of predicting properties of elements that hadn't been discovered yet. For example, gallium, Ga, had not been discovered when he made his periodic table. He left a blank for it, and he predicted the properties of it, said it's going to react like this, it's going to be about this size, about this mass, about this density, and he was really very close. So he did predict the properties of some unknown elements with pretty good accuracy. So again, here is Mendeleev's original table, and we already kind of talked about this, how we've got some similarities, like a lot of the same elements are in group one. A lot of the same elements are in group two. It does increase by atomic mass. Ours basically does, but more atomic number. And obviously, our current table is larger because more elements exist today than did in 1869. So by the time we got to 1914, more elements were known. And Rutherford's gold foil experiment had been performed, and it was now accepted that the atom contained a dense positively charged center, and we knew about protons. So Moseley did some work with elements and found that they all differed by one proton. So he rearranged Mendeleev's table and said that protons was a better arrangement than mass, because mass didn't always go up by even increments, and then concluded that the regularity of properties is a function of their atomic number, and that is our modern periodic law. All right, so our modern periodic tables that are sitting in front of us are arranged by increasing atomic number, which is equal to the number of protons. And the original periodic table developed by Mendeleev was arranged by increasing atomic mass.